Hi, my name is Rebecca Caudill. I teach at Port Elementary in Johnson County, and the title of my grant this year is Imagineering. So, my problem of practice is loss of engaging and hands on experiences for students while transitioning in and out of the classroom due to lack of embedded technology as well as limited in class and take home building resources. So, my title is Imagineering. And what it entails is reimagining engineering in and out of the classroom. Because we all know that at any moment, a teacher could have to experience remote learning again. Thankfully, right now, though, we are in school in person, and we are all very, very pleased with that. So, my research questions, the first one is if we are in person. If schools continue in-person learning for the remainder of the school year, will increased blended learning instruction and additional building materials boost student engagement? Now, if the need arises for remote learning, will increased blended instruction in the classroom and supplemental take-home resources preserve engagement and make for an easier transition for students? I have observed students who are discouraged because they didn't get to complete their product due to lack of resources in class. I've also witnessed students in despair whenever the teacher assigned a challenge during remote learning and they didn't have materials on hand at home to complete the project. So that is what brought this all about, and that is where I got my questions from. My stream classroom has an established studio for each subject area. However, even though each discipline has its own designated space, my ultimate goal is to provide an interdisciplinary environment for my students. For example, I will focus on the engineering studio and bring in other subject areas as well as additional technology. In-class materials that could also serve as take-home resources will be beneficial in the event that remote learning is essential. So students will begin by completing a pre-assessment in the form of a short survey, which we just did last week. And this will focus on their feelings and their attitudes toward technology being included in instruction. So this is going to help me, or it did help me, identify their interest levels. So let's go through these. The first question was, which studio listed as your favorite? And as you can see, engineering is here in the green, and it was not the favorite. So that tells me I really want to make it more of a favorite amongst my students. Now, the next one says, how do you feel when teachers include technology into instruction? The blue shows you 65.5% of students said that technology makes learning more meaningful. And if you add 30.4% to the 65.5, technology in the classroom doesn't change my feelings about the lessons. I want to improve that. Number 3, when a teacher includes technology into instruction, are you more excited about the lesson? So we had 36% say extremely more excited, and 43% said a little more excited. Now you combine that, and that's overwhelmingly the information that I need. Technology does make students more excited about instruction. And then I went on to ask about Flipgrid. How do students feel about creating Flipgrid as an assignment? We had 33.5% say, I love Flipgrids for school-related lessons. And then add that 31.2% who said, I kind of like creating Flipgrids. So still, if you put those two together, overwhelmingly, they do appreciate the technology added in. The next one says, would stream class be as exciting without technology? Overwhelmingly, 80.3% of students said no. So we must embed technology in instruction, especially in a stream lab. And number 6, do you feel engaged in your engineering studio? 96.5% of students said yes, they already feel engaged in their engineering studio. So that gives me hope that even more materials will help those other few students be more engaged during engineering? And the last question that I presented students with, are you more engaged in your engineering studio when you have a variety of materials to build with? We had 96% of students say yes, they are more engaged with a variety of materials, which is what I want to do. Okay, now let's get to my engineering studio. This is how this will go. They've completed their pre-assessment. Now it is time to get the materials and see what we can do. So students will be presented with various engineering challenges, and they will use developed rubrics for all activities on the elements of the engineering design process. And so this includes, first, they have to ask, what's the problem? Define the constraints. What is their goal? So most of the time, this is where they have to read their challenge card. If we go back and look, right here. Here's their challenge card. Each group must complete one blueprint page using the materials provided. Use the engineering design process to invent, design, and build a spacecraft. So with that being said, they have to ask, what is my challenge? What do I need to do? The next step is to imagine. They get together, they work as a team, and they brainstorm. They choose a solution. They choose the best one and they go with it. Step 3, plan. Draw it, make a materials list. This is where the blueprint comes in, as you saw on the challenge card. So before they're even allowed to touch their materials, they have to get together and they have to draw it out, make a blueprint. Step 4, create it, build their product, make it and try it out. What works and what doesn't, which leads us to step 5, improve, make it better. Figure out what worked, what could be improved upon, and modify the design. And then with my grant, I have decided that my engineering studio needs more hands-on materials available, such as magnetic building sticks and blocks, straw connectors for engineering building, Picasso tiles, creative flakes. We have STEM master building toys, the little star flex, puzzle building blocks, just to name a few. So here's some examples of the resources that we are going to be using in our engineering studios. So using these items, students will build and create products based on various challenges presented to them. So once they have finished their products, I will assign them a Flipgrid. So students will be expected to explain their process in a detailed summary while showing their completed project. I will be able to evaluate the student engagement through classroom observation while students are collaborating and building their products. I will also know if blended learning makes an impact on student engagement by viewing their Flipgrids. This will tell me how excited they are about their innovations, and this will help me see their engagement. So if remote learning becomes necessary, I will easily be able to evaluate student engagement when viewing their project summaries on their Flipgrids. Now, the blueprint is part of a rubric that the students have to follow. They will be completed by students on paper. A lot of times I'll give them a blueprint so that they can draw on paper. I also can create a Google Doc or have the students create a Google slide to where they will have to draw it on their computer or their Chromebooks. That's another idea on how to embed technology. And here we have some examples. You can see the blueprint. Students are building after they plan. They are really excited about these creations so far. I cannot wait to see how the materials will help with the other challenges that I will be presenting the students with. So this is just our first round with some of our new materials. Hopefully by spring, I will start to really get an idea of how the embedded technology and the additional resources will help with student engagement in my STREAM lab. Hopefully, in-person instructions will continue. We can all keep our fingers crossed on that. And I would like to end by saying, Katie Linder states, blended learning is not just a trend, and we're starting to see technology integrated in really intentional ways. So I hope to prove that planned blended learning should intentionally take place in classrooms to increase student engagement in order to preserve a hands-on learning experience, just in case a transition to remote learning is necessary.